Okay, so next we're going to talk about memory systems. And the way that I like to think about the formation of memory systems, I like to use a fairly archaic example of getting a phone number or an email address. I don't think most people in the audience use phone number or collect phone numbers the way that you and I used to back in the day. But back in the day, when you used to meet people at like conferences, which is where we meet people now, you might see someone and say, "Hey, you have some pretty interesting ideas. Let's meet and talk a few times." So you exchange phone numbers or nowadays maybe email addresses. And so when you get that piece of information, that email address or that phone number, someone whispers it to you or tells you what it is, before you get to write it down, that's a piece of sensory memory. So you have to pay attention to that so you don't lose it. So if you're at a conference, someone gives you their email address and their phone number, 5619345, whatever it is, and then someone says to me, which could happen to me, "Hey, Neil, there's free coffee or there's free bagels over there." And you go, "Oh, off I go." And then you lose track of that phone number. It's lost forever unless you get it back in a different setting. So that some people call that sensory memory. Um, and so that's really memory that you are able to hold on to without getting distracted. So let's say you get that email address or that phone number, and then you call or email that person several times, and you actually old school write out that email address or click out that phone number. So you're rehearsing that information. So there you're taking that what was formerly called the short-term memory, and you're rehearsing it and turning it into more of like a long-term memory. So that's something and this is what you do when you study. Basically, you're trying to turn this piece of information into a long-term memory that you can pick up or when you need to. So that's what rehearsal is all about. I like to think about that as being a function of the hippocampus and the PAPE circuit, which we'll talk about a little bit later on. You would think that would be all that you need to form your memories, but there's another system, and we know this from lesions, from lesional studies with patients, and Dr. Venemeyer will talk about this in a bit. But you take that piece of information and you practice and you think about it over the course of months, maybe 6 months or so, and you're able to consolidate it. And then you're able to form it into what we call a remote memory. So these are memories of things that happened months ago. So I had always been taught to think of it as something that happens more in the cerebrum. And basically, you don't necessarily need your hippocampus to retrieve that information anymore. But let me defer to Dr. Menemeyer on some of the anatomy on that.
Well, I just think sometimes it's useful to understand the role of these different components in memory systems. And memory systems are distributed through the brain. So I think what you've done a nice job of summarizing the slide is if you got a short-term memory system, and this relies quite a bit on the prefrontal cortex. That's where you rehearse information in mind. That's where you manipulate information. It's also a part, and it has direct input to the hippocampal systems that are involved in laying down new memory traces. So in the medial temporal lobe, the job there is to form new memories or to override old memories, and we call that modification. And then when you get to the remote memory systems, it's a bit of both going on, okay? So if short-term memory is about retrieval and rehearsal, and long-term storage is about the medial hippocampus forming new memory traces, remote memory systems are kind of both. And I'll give you an example. Let's say you're experiencing an event with one of your siblings a long time ago, and then 20 years later, you compare notes on what did you see during that event. My experience is that my siblings typically have a very different memory of it than I do. And the reason for that is that you retrieve that memory back into your frontal lobes over time, you process it again, you put some new context on it, and then you use your hippocampus to store it as a modified memory. So your hippocampus is involved and it's overriding the old memory. If you do that 40 or 50 times over 20 years, you end up with a very different memory than you started out with. So remote memory is something that's typically involving both systems. So you bring information back into the frontal cortex, and then you may modify it and store it again with the hippocampus. The reason these distinctions are important is that when you have a lesion that affects the prefrontal cortex, you get memory disturbances, but they're of a different type than the lesions that affect the medial temporal cortex. Prefrontal cortex lesions primarily are deficits with retrieving information. The medial temporal lesions when they cause amnesia, it's more typically forming new memory traces. And I think this is where you're going to go with your next couple of slides.
Yeah. So one of the things that I was always taught when it comes to long-term memories is to think about the difference between implicit and explicit memories. And so a lot of the hippocampally mediated memories that we think of are more like explicit or declarative memories. So think of it as like facts or episodes. I know the story and I'm going to be able to repeat that story to you, or I know, whatever trivia you happen to know in the back of your mind, versus implicit memory, which I was always taught to think of as, and I know how to do something. So whether it's procedural skills like riding a bike or ice skating, or some sort of emotional or priming effects, whenever you see, I'm a 49ers fan, whenever you see Patrick Mahomes, you're a little bit sad because he beat your team in the fourth quarter, whatever that might be. So generally, I was always taught to think of the explicit memory as a hippocampally mediated system.
One of I think that for most of the medical students, they're very heavily dependent on their explicit memory system, and they're going to answer questions correctly. They're going to use that declarative semantic information in particular. What about the implicit stuff? Is it very important? One of the things I like to ask the students is, if you have a patient with Alzheimer's disease and they don't ever remember talking to you, or they don't remember seeing somebody just 10 minutes later, does it make sense to do physical therapy with those kinds of patients? And the answer is yes, it does actually make sense to do physical therapy with them. And the reason is because you can work on the implicit memory system rather than the explicit memory system. So implicit memory systems seem to be more dependent on the integrity of frontal and of motor and sensory cortices than they are medial temporal lobes. But the explicit systems seem to be very dependent on the medial temporal lobes. Turns out that patients with Alzheimer's disease have a lot of damage in the medial temporal areas, but they have relative sparing in motor and sensory areas. So physical therapy can teach patients with Alzheimer's disease to transfer out of a bed into a wheelchair. They can learn skills like that, even though they don't ever remember doing the physical therapy or who their therapist was. So these distinctions can be pretty important functionally when you're working with patients.
Yeah, really practical information to always remember for your patients too. All right, so long-term memories. I suspect that our audience is going to have seen some sort of pictures like this as we go. At least for me, the main things that I want them to get out of this slide, and this is a picture of some of the anatomy involved in long-term memory, is thinking about CA1 and CA3 as they happen in the hippocampus. So those are rich in pyramidal cells, and pyramidal cells are really, they're greedy when it comes to oxygen. That's sort of how I like to think about it. So when there's a lesion to that area, especially if it's a hypoxic lesion or something like that, those cells are much more likely to get damaged than some of the surrounding cells. And as a result, if someone has a lesion to this area, whether it's hypoxia or some other causes, like herpes encephalitis can do this as well, your patient, their memory can get affected. For this slide, it looks kind of messy, but that's sort of the main thing that I think our students should take out of this.
I was just thinking that I keep referring to the medial temporal lobe, and sometimes the slides say hippocampus, but I just want the students to recognize that we're talking about the same thing because the hippocampus is in the mesial temporal area.
Yeah. That was one of the things that always confused me, even up through residency a little bit, because we have a lot of different words for the same thing. The next couple of slides are sort of just diagrammatic slides, and so this is just an extension to show you the PAPE circuit. And I don't think it's necessary for us to go through every single step. You guys can go through that on your own. And then just to show you where these are within the brain, here's a picture of the PAPE circuit anatomy as well.
PAPE circuit it begins in the mesial temporal lobes in the hippocampus. If it has a beginning, it's a loop, but you could start there in the subiculum. And then what it is a reverberating loop that hits a number of structures, which you can learn by kind of going over this diagram. We've learned over time that it's important in memory because lesions along various parts of this loop often cause amnesia, or they cause memory impairment. So we've kind of discovered that PAPE circuit is important in memory because several structures they're involved in it when lesion produce amnesias. So that's kind of how we came to that understanding. But it's one way that memory information enters the parahippocampal cortex and then reverberates and synapses back onto parahippocampal cortex. So that's kind of something to keep in mind with this medial temporal memory system.
Yeah, we keep talking about that region of the brain. It'll become more evident why in a couple of slides.